Section 7.5, modeling data using logarithmic functions. So we're going to represent data using a logarithmic function and interpret the graph to solve the problem. So because this is the same chapter as exponential, it's going to be important that you do know the general shape of logarithmic functions so that you can recognize which type of regression to use when solving problems. Okay, so here's an example. The flash on most digital cameras requires a charged capacitor in order to operate. The percent change Q remaining on a capacitor was recorded at different times t after the flash had gone off. The T5 flash duration represents the time until the capacitor is only 50% of its initial charge. The T5 flash duration also represents the length of time that the flash is effective to ensure that the object being photographed is properly lit. First, we're going to construct a scatter plot for this data. Then we're going to determine the logarithmic model. And then we're going to use the model to determine the flash duration to the nearest hundredth of a second. Okay, so we go to Excel. We enter in the data, and this is nothing new. We highlight. We go to Insert, Scatter Plot. There we go. So you can see how that's kind of the shape, a logarithmic shape. A decreasing function, so we would expect a to be negative. Okay, we go to layout, we go to trend line, more trend line options. Instead of exponential, linear, or polynomial, guess what? Logarithmic. We want to display that equation. And there we go. Here's our equation. So notice there is negative and there is a constant. So this is the function that we're going to use. Negative 0.1 ln x plus 0.4597. Okay, the next part says using your model, determine the T5 flash duration. So now we want to know at 50%. So we have really close to 49 to 50 right there. It's going to be very close to 0.7. What we could do is we could take the equation that we got, which was y equals negative 0.1 ln x plus, what was that value? 0.459, I think it was. 0.4597. And what we would do is we would put in the value of 50. So this is just a matter of going to your calculator. There should be a button on your calculator that says ln. Sometimes it's above log. If you can't find it on a conventional calculator, go to Desmos and it will do calculations for you as well. So if I just did, what was it? Negative 0.1 ln of 50, okay, plus 0.4597. Wasn't that my equation? I think I did something wrong. Right. Negative 0.1, because I want to know at 50. Yeah, no, I did it right. I'm second guessing myself. Okay, where's my equation? Right here. So you can see that the answer is 0.068 or 0.07. Okay, so it takes 0.07 seconds to get 50%. So that's all we're doing in this section. Absolutely nothing new. Oh, wrong section. There we go. Absolutely nothing new. Information right here. Logarithmic function may be a good model for a set of data if the points on a scatter plot form an increasing or decreasing curve, where the domain is restricted to the set of positive real numbers. The general form looks something like this. Graphing calculators and spreadsheets are going to give you sometimes the constant plus b ln x. I think ours gave b ln x plus a. I think Excel gave it different. Anyways, same idea. A logarithmic curve of best fit can be used to predict values that are not recorded or plotted. Predictions can be made either by reading values from the curve, so actually looking at the curve and saying, okay, 50 is about somewhere here, or you can use the equation and put values in.